Okay guys, so welcome back for the physics class of 100 days challenge program for JEE mains as well as NEET, right? So this is the day 10. So today's topic is so rolling without slipping. Okay, so up to last 9 days we have seen different topics which we have seen in class 11th. So this also class 11th topic only, rolling without slipping. Okay, so class 11 physics for JEE mains plus NEET. We'll go into this slide now. So what is rolling motion? We know motion, right? But what is rolling motion? So rolling motion, a body shows a rolling motion when it moves linearly and rotates simultaneously. So moving translate, no, in the translate position, if object is moving, that will say a normal motion. But in the same case, it is moving and again it's rotating. For example, if we take a wheel, so it is rotating as well as it's moving in a straight line, no. So those things are called as a rotational or rolling motion. Okay. Hello. Goodbye. Name itself goodbye. Okay. So example, a wheel moving forward without sliding. See here, if I take a vehicle, okay, I'm not good in drawing, consider this is a vehicle or bus, okay, which is going in a road. So if it is moving in this direction, no, what will happen? This going front as well as it rotates, no, it will rotate like this, and as well as it's going front. This one is said to be a rolling motion. We'll say this as a rolling motion. Okay. So if you take this giant wheel, no, simply it's rotating. No, it's rotating, but it's not going front. Same, if I take a wheel, it's rotating as well as it going front. Those things rolling motion. Next, condition for rolling motion without slipping. So without slipping in the sense, we'll see here at the point of contact in the sense, so this is my wheel, and if I take the surface, no, which one I will say point of contact? This is my point of contact, I will say. This one is my point of contact. With the ground, velocity relative to the ground is 0. So at the point of contact, the relative velocity is 0. See, that's the point they have given here. So mathematically, how I can say velocity we know, right? But for this rolling motion, V is equals to R omega, where R is the radius of the wheel and omega is the angular velocity. So linear velocity, radius, angular velocity. So the thing you should remember, if they are asking about a velocity, V is equals to R omega. Right. If they are asking about angular velocity, omega is equals to V by R. That's it. Fine. Next one. So total kinetic energy. So kinetic energy, we know the formula is half mv square. But in case of rolling bodies, the formula is half mv square plus half I omega square. So for translation, it is half mv square. I will write it here. For translation, kinetic energy for trans is equals to, is it visible, right? Or I should use some other color? Okay, I'll use black only. So for kinetic energy of translation, body should be equals to half mv square. Kinetic energy of rotation, okay, rotation is separate, rolling is separate. Rolling in the sense rotation plus rotational translation, and is equals to half I omega square, where I replace m with I, b with omega, that's it. So if I write k rolling, kinetic energy rolling should be equals to adding the both of them, kinetic energy of translation plus rotation. Okay, so half mv square plus half I omega square. So that's the formula they have given here. So translation plus rotational energy. So I is the moment of inertia of a given object. If we are considering as a ring, moment of inertia will be like different. If you are considering as a disk, moment of inertia will be different, right? So that's what. We'll go for the next slide. So moment of inertia of a common rolling bodies. So we know that we have seen about the moment of inertia in the last classes. So some common bodies we have seen, like I is equals to mr square for ring, and then for the solid disk of mr square, solid sphere 2 by 5 mr square, hollow sphere it is 2 by 3 mr square, and the cylinder is half mr square. So you need to remember the moment of inertia formulas for the bodies. Okay, so sometimes they may give the moment of inertia directly in the question, but sometimes you need to remember, but no need to worry, those basic moment of inertia only they will ask. So rolling on a inclined without slipping. So when we are talking about translation, acceleration I will take A, but when they are in the rolling, no, it is A is equals to g sin theta by 1 plus I by mr square, okay. This is the formula, guys. Okay, you need to remember A is equals to g sin theta. When they are inclined, normally we know inclined plane acceleration is g sin theta, but when they are in the rolling without slipping, the formula is g sin theta by 1 plus I by mr square, where I is the moment of inertia. So if I consider the moment of inertia, no, like this is the thing. One more thing you can keep in mind, smaller I means faster acceleration. So when moment of inertia is less, acceleration is more. So it's inversely proportional, right? So for ranking purpose I have given for some specific things, sphere greater than cylinder, greater than disk, and ring. Okay, so when they are asking about the relation, so some 4 objects has been given. What is the moment of inertia, like what is the acceleration of the given object when they are in the inclined plane, they are asking, right? So which one have the more acceleration? For example, if I take sphere or else cylinder or disk or ring, okay, this 4 thing I am taking, and they are asking about the acceleration. Okay, they are asking about the acceleration in ascending or descending order. Then you can find the moment of inertia. Which one having more moment of inertia, that one will have less acceleration. Which is having less moment of inertia, that one will have more acceleration. So smaller I means faster acceleration. Okay, so there is the formulas. Okay, next one, the notes, key notes for role of friction. So friction is a static, not a kinetic in a pure rolling. In pure rolling, friction is static. Okay, like that's why it's rolling without friction. We say it ensures no slipping. No slipping in the sense if there is no friction, no, we won't slip, right? If we are walking in a smooth surface, right? If you are walking in a smooth surface, those examples we can take. Energy is conserved, so no loss of energy due to friction. If there is a friction, no, energy will be lost. So suppose I am projecting an object in the smooth surface, it will move smoothly, but if there is a friction, it will oppose the force. That's when they oppose, no, the force will reduce and it will stop. That's what. And then at point of contact, velocity is 0. These are the things you should be keep in mind. So when they are asking about, I mean in the question they are mentioning velocity is 0 in the point of contact. So I can say it is a pure rolling, or energy is conserved. It's a pure rolling. It ensures like no slipping, pure rolling, friction is static, pure rolling. Any of the thing they can ask. They won't ask, like they won't give the 4 points, but they can give any 1 point and they can ask the question. So formula, okay. So these are the formulas, like V is equals to R omega kinetic energy and inclined acceleration also, okay. These are the formulas. So the first question, a ring of a radius is rolling over a rough horizontal surface with velocity V naught, 2 points located at A and B of a rim of a ring. The angular velocity of a point A with respect to point B. Okay, you can try the formula and give answer. Okay, we'll see the answer. So from this point to this point, no, right. So what I can say, where's the pen? Yeah. So velocity from this point to this point 2v I'll take, and omega is equals to, like I want to find the angular velocity with A respect to B, no, should be equals to VAB by 2R, because from this point to this point it's R, from this point to this point it's R again. So I can say 2V naught, V naught again V naught by 2R, where it is V naught by R is the answer. This is the answer. Option 2. Okay, we'll go for the next question. I'll zoom it out this one. Okay. A system of a uniform cylinder and a plate is shown in the figure. Okay, the figure is not given, right? Okay. Leave about this. All the cylinder are identical and there is no slipping. See, I'll give the figure here. Suppose this is the surface, identical, and there is no slipping at any contact. Velocity of a lower and upper plate, okay, V to V. So let me consider there is a cylinder like this and a plate is there. Okay, plate is there. See, this is the cylinder like this and there is the surface. I have not drawn in the 3D shape, I have given in 2D shape. Okay, this is the cylinder and this is the surface. Again there is one plate on this, again one more cylinder they have kept. Okay, this is the figure. Imagine that. So velocity of a lower and upper plate is lower and upper plate. So they have given the velocity of this plate and this plate. It is V and 2V, V and 2V. So respectively, as okay, leave about the figure. The ratio of angular speed of a upper cylinder to the lower cylinder. Angular speed I need to find. Okay. Imagine guys, this is the surface. I am keeping the cylinder like this, and one more plate I have kept on the cylinder. Again on that plate I have kept one more cylinder like this. Okay. On that cylinder again I am keeping the plate. So two plates are there, two cylinders are there. At last the surface. So surface velocity is 0 and this velocity is V, the first plate. Second plate velocity is 2V. Okay, 2V. Suppose the plate is moving like this, one more plate will come in the opposite direction. Right, in the opposite direction I can say. So we know that like omega first, well, like 1 to 2 I'll take, like ground to A, GA should be equals to velocity, initial like this is the one velocity and ground velocity is 0, right? So minus 0 by 2r for this one omega AB, this is A I'll consider and this is B I'll consider, should be equals to V1, if one is going in right direction, immediately the second one will coming in the left direction. So what I will take the relative velocity, V plus 2V, no? In opposite direction means in the same direction I should subtract. In opposite direction velocity will be minus, I mean minus of minus plus 2V by 2R. Okay. So I need to find the relation, angular speed of upper cylinder to lower cylinder, that's it. So upper cylinder to lower cylinder in the sense, first one 2R will get cancelled and V 3V. So 3V by 2R by V by 2R. RR cancel, VV cancel. Answer is 3:1. This is the answer. So option 2, 3 is there. So 3:1 is the answer. Okay. The next question is, okay, a uniform disk of a mass m and a radius r rolls without slipping down a fixed plane that is inclined at an angle 30 degree to the horizontal. The linear acceleration of the disk. So we have seen the formula, right? A is equals to g sin theta for the inclined plane, but for these cases, no, the formula is A is equals to g sin theta by 1 plus I by mr square. Okay, I by mr square. So this is the formula I should use for the acceleration when there is without slipping. Okay, you can take the formula and we can go for the equation. A is equals to g sin theta by 1 plus I by mr square, where I is the moment of inertia and r is the radius. We'll go.
Moment of inertia is not given.
Not given in the sense like it's a uniform disk, right? So uniform disk in the sense, what is the moment of inertia here? Disk of mr square. Okay, that's why I told whenever you are doing these kind of problems, you need to remember the moment of inertia for some cases. So of mr square. Okay, I'll write the formula first here. What's the formula? A is equals to g sin 30 divided by 1 plus moment of inertia, that is of mr square by mr square. Mr, that's it, no? This is the thing. Now what I can say here? G I know, that is 10, angle 30, sin 30, mr, it's mr square or mr? Mr square. So mr square will get cancelled, and this one LCM.
3 by 8.
So 10 into 1 by 2 divided by 1 plus 1 by 2, which is 3 by 2. So this is 5 by 3 by 2. Again it will be 10 by 3, which is nothing but 3.3 or 3.4. Option 2. Hope you got it now. Like only the direct formula I need to apply and the angles. Okay. And we'll see one more question that's I'll give as a homework and we'll go. Okay. You can take this question as a homework, okay? You can try it and give an answer in the comment boxes. In a game of a billiards, a person hits the ball with cue such that it rolls without slipping on the table. Like billiards is there, no? By using the stick, no? Like he is hitting the ball, okay? Like with the cue such that without slipping on the table, if the radius of the ball is 10 centimeter and the mass is 100 gram, where he would have it above the surface. Assume the surface is sufficiently rough. Take this question as a homework and try it. Okay. Okay guys, from this we will wind up, and we'll meet in the next classes. Okay, bye bye.
Books are black slides.
Backslide.